Hey guys, it's me Sharan. So today I'll be doing a video about physics. So last class, according to the timetable. So guys, I have changed the timetable to a little bit because I'm not a major in biology, so I'll be removing biology and putting chemistry or chemistry. I'll be doing any one. And the thing is that I'm removing Sunday because trust me, I really need a break and I'm tired. So the thing is that let's look at the renowned or updated timetable. So Monday is physics, Tuesday chemistry, Wednesday physics, Thursday French, and Friday French, Saturday physics and chemistry. So today we're on Saturday. So I keep doing always chemistry. So now let's do physics for once. So I have already made a video about physics lesson 1 and also made a live about the revision of lesson 1 and the laws of motion and Newton's laws. So now I'll be doing physics lesson 2 optics, which is 10th standard, 10th grade, very very important, and state board syllabus. So now let's go over the textbook page by page so that guys you'll understand much more better. So there are properties of, on page 16 we can see the page title optics. So it says that light is a form of energy. Light always travels along a straight line. Light does not need any medium for its... so light is a form of energy. So yes, light is indeed a form of energy, like solar energy, light energy, because solar energy needs light. It needs sunlight to converse. And the second one is light always travels along straight line. So yes, light always travels in a straight line unless if something's there, you'll just bounce back or just bounces back and forth. Thing is that light does not need any medium for propagation. It can even travel to vacuum. Yes guys, you may ask me, Sharan, how does it even travel to vacuum if sound can't even travel to vacuum? So guys, imagine the sun to earth. Between, what is that? Does not air, solid, liquid, anything. It's just gas. I won't say it has gas, but it's rather vacuum. So the light from the sun takes about 6 minutes to reach the earth. So light can indeed travel in vacuum. And the speed of light in vacuum or air is c is equal to 10 into 10 power 8 ms minus 1. Since light is in the form of waves, it is characterized by wavelength, which is named by lambda, a Greek letter, and a frequency v, which are related to the following equation: c is equal to v of lambda. So c is the speed of light. So speed. C is the speed of light. C is the velocity of light.
Slow.
One second.
Can you speak slow? Go share it. It's good.
Okay, I'll try to speak slowly. So,
I get you this. I'll cover this one.
thank you, Sir Dave Raja. I don't know who you are, but thank you for the support and for watching the live. So now, c is the velocity of light or the speed of light, where v is the frequency of the light and a is the lambda, which means a form of wavelength. And the sixth point is that different colored light has different wavelength and frequency. This point tells that, so the rainbow colors, right? So Vibgyor, so V, like, let me give you a short example. So the sixth one states that different colors of light have different wavelengths. So Vibgyor. So V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, R for red. And let me look at the chat. So let me look at the chat. So someone said, can you enumerate the speed of light? Yes, I can. So first I'll teach this topic. So Regia are the colors of the rainbow, where violet has the shortest frequency, whereas red have the highest frequency or wavelength. This is the downward wavelength, which is one. And this is so as now I will try to enumerate the speed of light. Speed of light, isn't it? So the speed of light I've just now told you can calculate the speed of light by the following formula. C is equal to V of lambda. So V is frequency. And lambda is equal to wavelength. So now by this formula, let's try to enumerate the speed of light. So the velocity of light is normally about 3.502 times the frequency of a normal wave. So with G, right? So there are 7 colors. Look at the middle one. The middle one has medium wavelength with the same time graph. So if you enumerate this, it will come about 2.523 times lambda. So what wavelength is 1, 2, 3, 4? So 4. If you multiply this one, it's 70. So 2.523 times 4, 21, 8, 9, 12. So you get 1, 2, 3. So it is 0.052 times 12.92. Since this is a multiplication, if it goes, it will become division. So 12.92 by 3.052. So why I'm putting a bracket is that we got to balance the equation. So if we balance the equation by, I already taught you guys about the lambda I, lambda r. So if you enumerate by lambda I times lambda r, the value is distinctive. So if you, to be honest, what is both in common? So lambda I times, so the value of I times r is different. So if you do it by the Penrose method that I have taught yesterday, or similar to Bodemas, by the lambda to r, these can form of lambda I plus lambda r. We're changing the multiplication to addition. So if this comes over here by lambda I r, we can get a formula of 299782458 ms. Because you're gonna know the speed of lambda I, which is the incident of lambda, which is of just remember 852. That's it. 852. And for lambda r, it's so if you substitute by PEMDAS, will get 199.782458 ms, which will take about 6 minutes to sunlight. Is Devraja, I hope you have understood what I have just told. So can you teach me max tomorrow? I have doubts on algebra and quadratic equation. So Devraja, if you are, I don't think I can teach maths because I'm only teaching. If you look at the timetable, okay, you know what? I'll try to teach algebra and quadratic equations tomorrow, Devraja, for you. So, and also teach you identities of algebra. So tomorrow, guys, I'm going to teach algebra. So now, this is a bit of light. So I hope you have understood, Devraja. Because thank you so much for watching the live. Because only 2 people are. I mean, you are the only one who's watching. And you see. So yes, guys, the sound line says that among the visible light, violet has the lowest wavelength and red light has the highest wavelength. When light is incident on the interface or between 2 media, it is partly reflected and partly refracted. So let's see. So imagine, guys. So the thing is that how light refracts and reflect is kind of different. So if you look, if the light ray comes in at exactly 90 degrees, imagine that this is air and this is water. The beam does not refract or reflect back. But if you slant it to incident is not equal to, so incident is equal to, because these are adjacent angles. So if you take this form of the geometry equation, so imagine that this is the incident ray. The reflected ray will slightly go towards here. Reflected ray. So this is a rarer medium and this is denser medium. So if it goes, so for example, we can check quickly. So Devraja said, Sharan, I understood the concept. Thank you so much for understanding. Is this the introduction to Snell's law? Okay, guys. Okay, Devraja. So I'm gonna go shortly into Snell's law. So first we look at a reflection and refraction of light. So first, this is the light ray going towards the normal, and let's look at. So just now we look at denser to rarer. Now look at rarer to denser. So this is water and this is water, this is air. So imagine I'm sending out a line, a ray from water medium. This will be the incident ray, this will be the normal, which will be N. And I told you, if it's rarer to denser, we'll go towards the medium. If it's denser to rarer, we'll go outwards medium. This is the main concept of reflection of light to different medium, guys. So, okay, now let's go for the next topic. Refraction of light is the second thing. So refraction of light is bending of light, while reflection is bouncing of light. So when a ray of light travels from one transparent medium to another obliquely, the part of light undergoes deviation. Just now I told you. So let me give you another example. So guys, if you have a glass and if you put a pencil, it will not look like this, but instead, why am I trying so bad? This looks like a cone. Okay. The pencil will slightly, because guys, this is air, this is water. So like I told you, right to denser, it will go towards the medium. So it will look like, so imagine that this is a normal, and this is that, so it will go like this. It looks like it's breaking, but it's actually not breaking. See it. So now let's look at the first law of refraction. So guys, so the first law states that so this is a plane and normal. The incident line, the incident ray, and reflected line lie on the same plane. See guys, this comes on the same normal, this comes on the same line. So this is the first law of refraction, where the plane needs to differ from which the image is formed, whether it's here or here. This is the most normal. So now guys, we're going to go to Snell's law, which is the second law of refraction. Let's switch it quickly. Someone said hi. Hi, Jotro, you're being Kuja. I think that's my mother. And Devraja. Alright, now should be good. Hi guys, hi. So now Devraja, so I'm gonna teach you about Snell's law, alright? Just type in S if you're gonna, look after it. Alright, I'm gonna do introductions to Snell's law. So Snell's law is that the ratio of sine of the angle of incidence, so the ratio of sine of incidence is equal to the ratio of sine of refraction. So this, and where these are equal to the refractive index of two mediums. So by this statement we can produce the formula, which is sine of incidence by sine of refraction is equal to refractive index of 2 by refractive index of 1. We do this because the planar angle and the linear angle does not lie in the same line as refraction goes towards the normal or outwards the normal. So we cannot either define it as 1 or 2 or 2 or 1. We can just take it as 2 or 1. Yes. So guys, next is the last topic that I will do today. Next will be scattering of light. So, dear Raja, I hope you have understood law or the second. Should I repeat? Alright, I'll repeat again. So, the second law of refraction is known as Snell's law, where Snell's law say that the ratio of sine of incidence or I is equal to the ratio of sine of refraction, which these two are equal to the refractive index of two medium. Where this, by looking at the statement, you can just create the formula where sine of I by sine of I is equal to refractive index of 2 by refractive index of 1. The reason, I've already said the reason why I took 2 is because of, if you look at the normal, the planar angle and the linear angle does not lie on the same line as, just look at this as a graph. Just for an example, so this is x-axis, y-axis. So tell me, does these look as an adjacent angle or not? Because, okay, no guys, this does not, because this lies on x-axis and this lies on y-axis and this lies on x-axis. So x and y are not similar. So let us take x as 1, y as 1. So is 1 and 2 similar? No. But if 2 and 1 are similar, we can take that 1 plus 1 is equal to 1. So there is still 1, so we can take a 1 out. So 1 is equal to 1. So we can take that 2 is equal to 1. Because of 1 is equal to 1, you can just say that 1 is equal to 1 plus 1, where if you take this one out, it will be. So that's why we took it as 2 and 1. So yes, I have repeated, and again I hope you have understood Raja. So I'll be looking at the last topic we will see in today's live, which is scattering of light. Next one will be so guys, imagine that this is a particle which can be of solid, gas, or of anything, or a molecule. So imagine if you, for instance, if you pass light to a spherical shape, it will try to reflect the light, because the light bounces. Because light, if light wants to scatter, it got to look out on a smooth surface like the white bulb, which is very smooth, of course, so it reflects the light. So this is known as scattering of light. So scattering of light, there are like two types of scattering of light, guys. So scattering of light. So there are two types of there are two types of scattering of light. Where elastic scattering means that the incident ray ray's energy is equal to reflected ray of energy. In monastic scattering means the reflected ray of what? Okay, so the incident ray, Ri, Ri is not equal to RF. So scattering of light, there are two types, which are elastic scattering and inelastic scattering. So elastic scattering proves that the incident ray's light energy is equal to the reflected ray's light energy, like the light that bounces off here and it goes back here. So since the energy is same, it reflects back. And inelastic scattering are the incident ray energy is not equal to reflected ray of energy. So that's why if like a dim light, if you look at a dim bulb, it will not scatter the light equally, as you can't even see barely anything. So that is known as inelastic scattering, and this is known as elastic scattering. So guys, I'm gonna end the live over right now. So see you guys tomorrow. This is me Sharan signing off. My mark is about 30 minutes now. So bye guys, I'll see you tomorrow. Bye Raja and Mom. I'll see you tomorrow. Wait, not tomorrow because I will not be doing a video tomorrow. Let's meet on Monday, guys. Bye guys. I'll just do the same concept. Tomorrow, Raja, I'm sorry I cannot do algebra. I will not do video tomorrow, so I'm gonna look at Monday. Bye guys, I'll see you tomorrow.